Let's work on more logarithms. Let's try to combine more logarithms now. Now, as you can see, in some of those logarithms, we have variables. In some of those logarithms, we have only numbers. So in the case that we have only numbers, it is important to remember that you want to end up with a single logarithm, and sometimes you will not be able to find the logarithm without a calculator. Sometimes you will be able to combine the logarithm into one single number. Okay, if you have variables though, like the problems, the second and the third problem, in these cases you cannot come up with a number. There is no way, because you have a variable in your expression. So you will just combine the expression into one logarithm. So in order to give you an idea, if you have something very simple, like let's say log with base log of x, then these can be written simply as one logarithm, as log of x to the 1/2. And if you want, you can rewrite that as log of square root of x. If you have something more complicated, let's say 1/2 log of x plus log of y, then again you have to look at the bases. Right here I have no basis, so I can assume that the base is 10, because this is the notation that I have. And I can simplify that. I can combine those logarithms. Whenever you combine logarithms, I want you to remember that the first thing that you do is consider the power rule. First, you consider the power rule, and then you consider either the quotient or the product rule. This is something that you should always remember. Quotient and product rule, it doesn't matter which one you perform first, but the power rule needs to be performed first. And this comes from the PEMDAS that you remember. It is similar priority of operations here. So if you want to combine that, then 1/2 log of x is going to be, as we calculated above, log of x to the 1/2. And now you have this plus log of y. So first of all, you perform, let me name those. This is number 3, this is number 2 quotient rule, and the product rule, I call it 1. So the first thing that you do is that you apply right here the rule 3, the power rule. You combine this into one logarithm, and now you see that you have a plus. So this means that you can apply right here the rule for the product. And this is going to be nothing else than the log of x to the 1/2 times y. And in this way I combined the two logarithms that I had right here into one logarithm that has only one argument. The base doesn't change, it's the same with the previous one. Let's assume that this base is 10. Now, let's look at other problems, the ones that I have already given here for you. So I'm going to focus on the first one, that is a little bit simpler. Remember that this is the priority that I should be follow in order to apply my rules. Right here I have 1/2, that is a constant that is multiplied by the logarithm. So what I need to do is I consider, of course, the base of the logarithm is 2, and I can write this as 5 to the 1/2 minus, I can apply the 3, the property 3, the power rule, into the second logarithm as well, and this is nothing else than log with base 2 of 7 square now. So what do? I bring my constants as exponents to the argument. My constant right here, I bring it and I make it exponent to the argument of the logarithm. Okay, now I can look right here and I see that the bases are the same. So I can proceed and I can use now the product rule. Number 1, So here I applied number 3, here I apply number 1. I apply number 2. This is not the product rule, I have a subtraction, so I apply the quotient rule. So what does this mean? This means that I keep one logarithm now, and I put everything in the argument of the logarithm. The numerator will be 5 to the 1/2, and the denominator is 7 squared. Can I simplify my numbers a little? I'll try. I'm not sure, and I cannot say for sure that I will end up with something like one single number, but I will try, because I can go further, writing the 5 to the 1/2 as square root of 5, and writing the 7 squared as 49. Now, obviously, the fraction that I have inside my argument cannot be changed, because 5 and 7 are prime numbers, so I cannot simplify further. So that should be my final answer for this problem. Although it may not seem simplified, it is not. I cannot go further. What I know for sure is that the logarithm that I came up with is one single logarithm with one argument, where I started with 2 logarithms and I combined them. Let's look at the second problem. Well, in the second problem, what I have is a parenthesis. A parenthesis go first, so as always, I need to, first of all, distribute the 2 to each one of the logarithms. So I have this, plus now 2, I need to distribute it, as I said, and I need to multiply this with each one of the terms inside my parenthesis, right? So I have this plus 4 log with base 5 y minus, don't forget that you need to keep your signs, 2 times 3, that is 6, log with base 5 of z. Okay, now after I distribute it, what I can do is I can start applying the logarithm rules, and I will start as always with number 3 right here. So what I want is to go ahead and work with number 3, meaning the power rule. So I have a power right here that I will bring up here as an exponent. I have another number right here, a constant, that I will bring up here as an exponent, and I have a third one right here that I will bring again up here as an exponent. So what I have is log with base 5 of x squared plus log with base 5 of y to the 4th minus log with base 5 again of z to the 6th. Okay, good. Now, I have 3 terms. The first thing that I want you to see is that each one of the logs that I have the same base. Since they have the same base, I can apply more logarithmic rules. Okay, now, you can apply either the product rule or the quotient rule. I usually go first with the product rule. So look at the first 2 terms that you have right here, this one and this one. They have in between them a plus, and they have the same base. So if I look at my product rule, I can see that I can combine the 2 logarithms into one logarithm with the same base, 5, with an argument that is nothing else than the product of those 2 arguments. And I'm done. I have combined the 2 logarithms that I start with. But I have a third term that is subtracted from the sum of the first 2. Now, since I have a minus right here, I need to apply the quotient rule. So what do I do, and why do I apply? Well, they have the same base. Since they have the same base, I can combine those logarithms and I can have 5 here. And inside my argument, I will have the numerator is going to be the first argument, and the denominator will be the argument of the logarithm that I subtract from the first one, z to the 6th. So anything that is after the minus will go at the denominator right here. And that will be my argument. So the final answer that I have is 1 logarithm with base 5 of x squared times y to the 4th divided by z to the 6th. And that's my answer.